So good morning. Am I audible?
Yes, sir.
Okay. So yesterday we have discussed various NoSQL databases. There are major four category of NoSQL databases, and those are key value database, column oriented database, graph oriented database, and document oriented database. Out of all these four different type of database, as a part of your syllabus, we have one NoSQL database, one document-oriented database in your syllabus. So that is MongoDB, and specifically, there is a strict reason behind it because this is the most popular document-oriented database in which is used in industry. So it is widely used for industry practices. So we have already started with it in the lab session, but we'll continue with that only. So we will continue with our discussion on the Mongo documentation only because that is the most recent and most latest set of functions and features available. So it's better to reference or discussion from with a reference to that documentation only. So, but before that, I just want to quickly go through the various theoretical aspect of MongoDB. What are the key features? One of the major key feature is its capability to distribute the data set across the node, across the cluster of computer. So if load increases on one machine, then you can distribute the load. That load can be from both the perspective. It can be from a storage perspective or it can be from processing perspective. So from any perspective, if the load increases, then you can distribute it to a different machine within the same network. And that process is called sharding. We will discuss how to do it in detail. Uh, like MySQL and unlike every other NoSQL database, MongoDB supports the very rich query features, or it has very rich query language capability to find out or to aggregate or to perform any analysis on the data which is being stored. Another quite remarkable feature of MongoDB is that its capability to deal with, or its capability to get implemented in various programming language. So you will find an official support for a majority of them, which is not always there for every databases, NoSQL databases. So it has a support for C, C Sharp, .NET, C++, Erlang, Haskell, Java, JavaScript, PHP, Python, Ruby, Perl. So all these are officially supported by MongoDB community, and that's why there is one more reason why it is so popular. So you can have any of this server technology along with MongoDB as a database technology, and it's easily installable. It's okay. So sharding, what is sharding? Sharding is basically you have a single database, but that single database is distributed across the cluster of machine which are connected in network. So you can build a network and you can have a hosted database on that network. Logically, from application perspective, you will communicate with a single endpoint. So the endpoint to communicate with that database will be single, but the way it will get handled by the MongoDB server will be in distributed manner. So that is the sharding. Now you can have a range based partitioning as well to distribute documents. So what you can do, you have, let's say you have a 10 million records. So you can find out or you can identify some ranges, and based on that you can distribute across the cluster. What it helps you, it helps in providing the major or better application interface because it's not a random partitioning. You have some kind of it's like a clustering, one group on one node, another group on another node. So from an application perspective, you can easily manage the or you can easily optimize the application performance. So that is another feature, and it can be turned on and off per collection. So collection, I think we know collection means a group of documents It's not necessarily to be of same structure. It can be of different structure or different schema. But collection is you can understand it like a table in relational database. So basically, this feature, sharding feature, you can turn off or on for specific to a collection. So sharding is applicable on collection, not on just the database. This will also help you to find out which particular collection is going to take a lot of burden from a data perspective. So you can just configure that collection for distribution. So that will again optimize the performance of the application. So this we have discussed. MongoDB is logically it's one database. Database contains multiple collections, and each collections can contain multiple documents. Unlike table structure in MySQL, here all documents not necessarily should be of same schema, which belongs to a single collection. So that is the difference. What are the reason why you should use Mongo? I should not say simple queries, but I should say the reach query capability. I think this statement is understatement. It's not just a simple, but it's also reach in context. You have almost all the capability which has an SQL is providing you. Its functionality provided applicable to most web application. Almost every web application you can use MongoDB as backend, because remember it was initially a document oriented database, but now it's kind of a hybrid database which has also a lot of SQL features like joins, etc. So that is also there actually in MongoDB. So that's why it's very highly applicable for any web application. So you can easily switch over to Mongo from any MySQL database, unless and until it has some complex transactional systems. So when you have a complex query, that means if you have studied DBMS, then there is a trigger, then there is the functions or procedures which has some kind of a logical structure which actually performs the queries on a separate tables, and that entire operation has to be atomic. So transactions was initially not supported in Mongo. Again, I will stick to the same thing that now transaction also gets supported. So you can have transactions as well. Uh, Easy and fast integration means that you don't have to predefine, you don't have to be ready with your predefined schema. You can start with the development, and obviously you require some data modeling, but you don't require a fixed schema. You can just have a group fields, or you can have more generic view, and then you can be more specific when you want when you start developing an application. So it's not like MySQL where you have to be ready with each and every field. Here that is not required. So with respect to the cap theorem, it has a CP approach. CP stands for consistency and partition tolerance. It supports both. We'll not discuss that in detail. Hierarchically, zero or more. This is what the phenomena which is widely popular in MongoDB. That means a database can be zero or more, or each database can have zero or more collection. Each collection can have zero or more documents, and your document also can be an empty one. So that is what we mean by this. I think we have enough discussion on this. So database, collection, document. So this is the comparison which you can make between two technology. One is on RDBMS and second is Mongo. So in both the technology, database table in RDBMS known as collection. See, the reason I am repeating this again and again, some of you might be feeling that why there is so much repetition of something, because the reason for that is whatever you have studied, whatever you will learn till now, you all understand from the the relational perspective only. So you must try to correlate it, and the hammering why I'm doing is the reason for that actually. So you will keep on doing the same thing. Collection is stable. Collection is stable. So then you will come to know that okay, yes, this is how I should model my database in Mongo as well. Then tuple or row, it's a document. Column is filled. For a join operation, you have a phenomena called embedded documents. Embedded documents means nothing but a document within a document. Like your address field contains three more fields: address line 1, address line 2, and area. So that is called an embedded document. We will see an example. Uh, Primary key in RDBMS, here you have a auto key generated by each insert operation on MongoDB collection. So that will work as the key attribute. Server and client, for MySQL you have MySQL D server. Oracle has also an Oracle server, and here you have MongoD. For client you have MySQL clients. On command prompt, when you execute the command MySQL, actually you are running MySQL client, which will actually communicate with the server which is already running, that is MySQL D. So whenever you are required to start the server or restart the server, you should execute this command, and that's why we execute this command. But whenever you want to perform some transactions, when you want to perform some queries, then we write MySQL. Similarly, MongoD is to be started initially. When you install Mongo, you should start this service. Once this is started, then you can write a Mongo command, and that will perform your client side. But this is basically a client from which you can execute the query. This is again a JavaScript based client. So this Mongo is implemented in JavaScript. Okay. So there are some rules for data modeling. I'm not saying rules because basically it's a schema-less design, but that schema-less design also needs some principles. So what are those principles? Whenever you are dealing with the document-oriented database, you should combine the objects into one document if you are willing to use them together. So you should not always create a joins when you are dealing with the document. So if you are converting or if you are shifting from one technology to another database technology, that means from MySQL to Mongo, it's not like every table will be converted into a collection. Are you getting? Otherwise, you are not actually utilizing the features or the efficiency of the NoSQL database. When you convert your relational application to the NoSQL application, your every table will not be converted into the equivalent collection. Actually, you need to find out the joins, you need to group that table together, and you need to create a common collections for 2-3 tables which are actually joined together. However, that will not work all the time. So otherwise, your entire table, sometimes your entire database will become a single collection. If you keep on adding everything into a single document, then that's why there is a provision for joins as well in Mongo as well. But apart from it, every one-to-one relationship, every one-to-many relationship, every many-to-one relationship, if possible, it should be combined together and to create a single entity. So you combine object into one document if you will use to them together. So obviously you need to make a choice over here, what to combine and what not to. Duplicate the data because the disk space is cheap as compared to the computation time, which normally we don't do in ERDRM. If you remember normalization, what is normalization? It's all about removing duplications. So we don't want to repeat the same thing. We don't want to store the same thing again and again. That's why we normalize the tables. Here it's interesting. It's different. It's better to duplicate rather than creating complexity of getting the results, getting the data back. So MongoDB design are actually more of write oriented. Complexity should be there on the write operation, not at the read operation. That is what the basic principle of this, or that is what the basic principle behind this theory. Whenever you are getting the data, that's at that time there should not be any complications. But when you are writing the data, okay, we will okay with that complications. Because when you are creating a duplicate, it means that every write operation you need to repeat the same thing. So if there are two duplicates of the same thing, then you have to update each and every one, or you have to create at both the location. So write operation is complicated, but we are okay with that. The application should be okay with that. But whenever you are required that particular thing, at that time there should not be complication. So your select query should be optimized. That is what the basic principle behind it. Your insert and update, you may require to have a different insert, or you may require to have a different update operation. That's fine, but read operation should be simple. And what is the why we have this kind of a phenomena? The reason for that is normally the read operations are performed more, and that's why it was suggested, if you remember, that it is not good for transactional systems, because in transactional systems the frequency of a read add operation are almost 50%. So almost every record you are writing or reading, you are equivalently writing or reading the both the thing. So any transactional data processing system, transaction means like banking transaction, etc., where you just one time you record that transaction, and then normally you don't require to read it. Or there can be any number of other transactional system as well. But in case of the online OLAP system, online analytical processing system, the frequency of read operation is much higher than frequency of write operation. So let's make write operation complicated, but read operation simplified, and that's the basic principle behind Mongo or any document oriented database. So you have to do perform a joins, you have to take care of joins while writing, but you don't require to perform a join query, because they are actually, there is no join, everything is embedded. So if you fetch a student, then student marks information, student tuition fee payment information, student achievement information, student event informations, everything will be there associated with that student only. So you don't require to get the achievement from another table, then marks or results from another table, then uh, the tuition fees related information from another table. No, you just fetch one student, you will get the entire profile of it. And that's why you have to identify that what is the application, nature of application. And that's why this kind of a database is very popular in this is a profile driven applications, where you have a user, you have an entity, and which is doing some task, which is doing some activities on that platform. You keep it all together to that user. So whenever user enters into its own domain, uh, the user will find it very easily, because everything is stored together, everything is being kept together. That's why you can improve on the performance. So this is the principle behind it. So you have to optimize your schema according to the use cases. Aggregation means a group by count, sum, max, mean, everything. That should be there within the schema, or it should be taken care by the schema. Server and tools, I think I told you that MongoD is it's a Linux version. Then in Windows you have mongodb.exe when you install Mongo on Windows, and that runs in a background. That actually takes care of that everything, sharding, etc. So, and the client is based on the JavaScript. So it's a JavaScript shell. You write some commands, and that will be executed. That command will be given to the server, and server will do the needful. So that is why we know the Mongo is a client. Drivers, as I told you, MongoDB has support for almost every language. So you need to install the drivers for it. If you want to install Mongo with Python, then you have to install MyPyMongo. which is official version of driver supported by Mongo. So for every language, you have a driver created officially by MongoDB. There are unofficial drivers as well. Unofficial in the context, sometimes that it's an evolving technology. So MongoDB has started. They have started with Java. They have started with C. But people are running Ruby. So what? And it's an open source. So what they will do? They will create their own drivers to deal with the Mongo. Later on, then Mongo also will write its own driver. So again, then that's why I told you that there are unofficial drivers as well, which can be used unless and until if official versions are not available. So the official drivers are always recommended. Another interesting property of Mongo is that remember everything in Mongo is a document. Document means key value, that means an object. So that can be all this what this driver will take care of. They will actually ensure that that MongoDB document gets converted to the equivalent feature of that language. For example, if you create a dictionary in Python, you can insert the entire dictionary as a document in MongoDB. In Ruby, if you create a hash, that entire hash can be stored inside as a document in MongoDB database. In PHP, you create an associative array, and that associative array, entire associative array, can be stored as a document in MongoDB application, MongoDB database. So that driver takes care of all this, that how they can convert the data into a data which can be understood, which can be represented by MongoDB document. Then there are some command line tools, Mongo dump and Mongo restore. This is a backup utility. You can create a dump of entire database in a single command. Mongo export and import. Mostly all these data are documents, so they are key values, so they can easily represented using JSON or CSV format or even TSV format. What is TSV? Anyone? What is CSV?
Comma separated values.
What are the other people are doing? Thank you, Prem. Yeah, it's fine, Fanny. I'm asking the other people who are silent. So, are you understanding what exactly I'm delivering? That's my question. Because now it creates a doubt when you don't interact. Say yes or no. Okay, thank you. So these are the tools which can be used for various. It's like a backup utility. You have a Mongo dump, Mongo restore, which will create a binary files. Uh, but sometimes you require a representation which can be used for a reading purpose as well. So you require a JSON object, you require a CSV object, you require TSV. TSV means tab separated value. So instead of a comma, this entire data is in tabular format, which is being separated by tab. Again, it's a text file only, but each column or each field is separated by tab. There is Mongo Sniff, which actually which can wire. It's a wire sniffing tool, which means that it will just keep a watch on what are the operations which are sent to the database, what are the commands which are given. Then MongoStat. MongoStat, it's an analytical tool which gives you the detail about timestamp based detail about the queries which has been performed on a server. So there are different tools, and these are all available when you install, I think, Mongo client. When you install Mongo client, I think all these tools are installed together with that. So it's not just you have to install a separate Mongo dump. If you install client, then you always have this Mongo dump also. Okay. So I think now we are starting with the CRUD operation. So before we discuss that CRUD operation, let us try to create or understand how to model the data. So let's say we have this example where we have a post which has a unique title. It's basically a blog. So there are a number of posts, and every post has a title, description, and URL. First property. Second property, every post has or it can have one or more tags. Tag means some string or some word which you are associated with that post. Normally, tags are used for what? Which operations can be means tagging are used for which purpose? Means what is the purpose of using tagging? What you want to improve actually when you tag something? Yes,
The
anyone?
communication between people,
Sorry.
improve, improvising the communication between people.
Right. To you are actually saying for some specific application. I want in general. Let's say, uh, if you remember in Gmail also you have a labeling feature. That means you can attach a label to a mail. What is the purpose of it? The basic purpose is that you want to perform the search operation in better manner. You when you tag something with some keywords. So let's say you are referring the literature and you found the article with respect to, let's say, augmented reality. So you will read it and you found it's useful. So what you will do, you will have some history record, and then you will say that this is related to augmented reality. So, and then you will have another article again that is also augmented reality. So what you will do, you will add a tag augmented reality to entire data. So whenever you need an article related to augmented reality, you can easily uh, search it. So tagging can improve the search operation. Okay, this is why normally we use tagging. Uh, so similarly here, every post can have one or more tags. Then every post has the name of its publisher and total number of likes. So by this we can get information that post has some kind of a like feature as well. Then every post has a comments given by users along with their name, message, data time, and likes. So that means every post can be commented as well, and that comment contains this information: name, message, date, time, and number of like or whatever, that some number in form of like. And on each post there can be zero or more comments. That means there is a provision of zero comments as well. So we have this information, we have this requirement, and now we want to build uh, a document for this. If it's in relational databases, then how many entities you can find here? How many entities? Okay, give me one entity. What is entity? Every post has some information, then every post has some tags. Okay. Then every post has a name of its publisher, your number of likes. Every post has the comments, which can be 0 or more. So from relational perspective, if I put it together, then this post has a title, description, and URL. Then other field is a tag, which can be 1 or more, 0 or more actually. Then you have a name, then name of publisher and total number of likes. So another two fields. Then comments, but that comment is actually the group of comments which can be name, message, timestamp, and like. So how many tables will be there if I build an ER diagram? How many tables will be there? Just go through it, just understand it, and let me know. See, this type of questions will be there if you have been as a part of your final examination as well, not just mid-sem but final. Data representation, data modeling. You will be given some requirements, and based on that requirements, you need to understand the document structure. So for that, you need to understand how. First you need to identify, because we are used to relational modeling. That's why I'm asking this. I'm not saying you always require relational modeling concept, but you know the relational modeling. So I'm asking you how many tables this database will have. 4. Okay. Uh, what will be what are the various tables will be there? Yes, anyone?
Sir, first will be of title, description, URL.
So
Then
you can
for
call it
tag,
a post table, right? You can call it a post. So post is one entity. Fine. Second,
then for comments we will have other table because comments itself have name, message, data time, and likes.
okay. So
Uh,
that will be a second entity. I call it comments.
yes,
So
sir.
post and
Then
comments. These are the two entities. Third,
even tags.
yes, tags are also multiple. So post has or have tags. So basically, this is which type of relationship? Each post can have 0 or more tags.
One too many.
One too many. Each post can have 0 or more comments.
One too many.
Right? So there are three tables, three entities. One is post, second is comment, and third is tags. Anything else which you can find?
So we can have table for publisher and total number of likes as well. Name
Uh,
of
I
publisher.
think
But we
publisher, you can say users is one entity, right?
yes.
Because
Yes.
who is posting this, so it's a user. So user
Yes.
is the fourth entity which I find. Number of likes is basically, it's a number actually. So it's a
Yes.
field. You don't require a separate table for it. हर
Hmm.
एक पोस्ट का एक फील्ड होगा जिसका नाम होगा लाइक, सो दैट्स फाइन. सो यू डोंट रिक्वायर सेपरेट टेबल. So I think you are right. 4 table: users, comments, post, and tags. If it's an ER design,
Yes,
right?
sir. Hmm.
Now let us try to convert it into uh, the document version. So as I told you that in case of document-driven databases, uh, I think I will take 5 more minutes for completing this topic. Okay. So basically, it's a document. So the first is the publisher who is posting this. So then you can have some name of publisher. Then you have a title of post. Then you have a description. Okay, again some description of that post. Then some URL. Okay, then you have a tags. Now tags can be 0 or more. So that means it's basically an array. An array of what? Tag is a single value, it's a string. So this is how you can manage the tag. Then you have a comments. Comments is also 0 or more, so that can be 0 comments as well or more can well. So that means it's an array. So now what that each comment contains? It contains the name of message, date, time and likes. So name, the actual content of the comment. So message, the timestamp. You will have some timestamp over here. Something like this. Obviously, it will not be in a string format. And then likes. You will have some number. Now there can be a multiple comment. So that means there can be a multiple embedded object. Right? So this is how your document will get structured. Is it covering every aspect? Every has unique title, description and URL. So there is title, description and URL. Then every post has one or more tags. So post has one or more tag. Okay. Then every post has name of its publisher and total number of likes. So name of his publisher is there. And then you have total likes. Okay. Total likes. Then every post has comments given by users along with the name, message, date, time, etc. So then you have a series of comments and that has name, message, comment, like. So that means this is how you should model your document for any application. Now you can see there were 4 table in case of ER diagram. If you build an ER diagram for this, there were 4 tables. But when you create a document-oriented database, it will get converted into a single collection, which contains everything about that post. So that post has comments, tags, everything will be there associated with that particular document only. So this is how you should design the document structure for any application. Obviously, it's a simple JSON document. So on the right hand side, you have only string or numbers only. But when it comes to the Mongo, this timestamp will be actually the Mongo timestamp. Okay. Then you have additional underscore ID over here, which will have some ID, which is a unique one. Okay, which will be created by, and this is basically an object ID, not. So it will be something like this. So when you convert this into the Mongo document, then it may change, but theoretically, the JSON representation of this will be this, and then you can perform all the operations, etc. So I hope this is clear. In the next session, we will be discussing the CRUD operation on Mongo. Today you have a lab, but I am afraid I will